Yeah, so before we start the video, I'll let you know that at some point in the video suddenly stopped, like it got stuck, something like this. But yeah, that's nothing more important than the actual content of the video. So yeah, I hope you enjoy the content of the video more than how funny my face looks. But yeah, that's enough for the editing. Um, Continue with the video. Hey everyone, welcome back to the channel. My name is Darsh Joshi and I'm a BTech Computer Science and Engineering graduate and I'm currently working as a developer in a tech company. In case you're seeing me for the first time, please don't forget to subscribe to the channel. And let's get started with today's agenda for this video. So in this video, we'll be covering core concepts of Python. These are basically the core concepts of any programming language, but because we are studying Python, so I've put Python here. So let's get started without further ado. The first thing we'll be studying is variables. Then we'll be studying about data types. And we'll also study about keywords somewhere in the middle of that. So yeah, that's all we are covering in this video. So let's get started. So by definition, variables are basically containers that are used to store the data. If you look at it in a diagrammatic way, um, let's say we have a variable x equals 10 and we'll put this here. Let's say this is your RAM or your memory. I'll just add text. I can't add text. Let's take it as B. So when we define a variable in this way, this specific value gets stored in one of the memory spaces, which gets allocated every time the program is executed. And this value basically is the label for this. Let me just type the text here, x. So x basically represents this value. Let me just write it more clearly so that it's visible. 1 and a 0, so represents 10. So whenever in the code this value will be called, it would point at this memory space which contains the value 10, and this value would be accessed whenever this is called. So if we take a look at it in a code format, while it's opening, let's differentiate between what we have so far. So here it's open anyways. Let me just show you. I was about to display. We have a variable x, and let's say it has the value of my name. So x here is the variable, and my name in this case is the data. Each variable has a name, and this name has some rules, which we call it as naming convention. These rules are not compulsory, but they are considered as the best practice, so it's good to know and implement. And this part data basically has two things. Data has a type and data has a value as well. In this case, the type is string and the value is my name, which is Darsh. So yeah, that's something we'll be discussing in one of the future slides. Let's see what we have in VS Code so far. So let's say we take a variable x equals 10 and we print it out as well. My bad for typing it out wrong. Let's say we are printing x. So when I click this button, x is a label for that specific memory space in which 10 gets stored. So when I call this variable here, this specific value gets called from the memory space and it gets displayed here. Pretty complicated if we take a deeper look at it, but it's quite simple if we look at it from a bird's eye view. So let's take a look at it in a bird's eye view for now. We'll be discussing in depth in the future. So back to the presentation, why do we basically need variables? So what do variables do is they improve code readability, they avoid repetition, and they make the programs dynamic. So variables have a property that makes it possible to change the value whenever we need to do that. So let's say we have a variable x again, and it is storing the value 1, the number 1, and after a few lines of code we decide that x should contain the value 10 instead of 1. So we can simply declare it like this, and it would replace the value of x to 10, like as I showed in this diagram. Here we were storing the value 1 in the first place. Getting by okay. When we assign the value 1 here, we basically put 1 here. But when we again reassign the value 10, then we did this. We changed the value inside the memory space. So yeah, this basically means that we can change the value whenever and wherever we want inside the code, which makes the program pretty dynamic in nature, which means that it can be customizable according to our needs. Let's take an example for how it avoids repetition. So let's say I have to take a list here. In this case, list. What is list, you may ask, but we'll be talking about that in a minute. So let's take a variable list equals 246, my name again, and my last name is. So let's say I need to do some operation on this list, but I don't have to repeatedly declare this list as we have done so far. So we'll simply call this variable whenever we need, and we won't be basically typing this part out or every time we need to use the list. So yeah, that's how we improve and work upon how we can avoid the repetition of lines of code inside the code. So, and code readability as well. So I'll show that in VS Code. So when I say code readability, I mean that we can just look at the code and understand what it's doing. Let's say I have a variable called first underscore name, and it is storing the value of my first name, and another variable called last name, and it's storing my last name for now. So if you come across this variable at any point in the code, then we know that this variable contains the first name of person, or this variable contains the last name of a person. So yeah, that basically means that the code readability is good, and we can read and understand the code without actually deep diving into it. So yeah, next up we have naming conventions for variables. These are the best practices for naming a variable. They are not compulsorily, we do not have to compulsorily implement these, but we can do it according to our convenience and if you want to do it. But we should do it because it's the best practice. It improves the code readability factor, which we discussed in the previous slide. So let's get to the whiteboard first. And the first tool is that not the whiteboard, we don't need. Let's say we have a variable first name again. I should not have put that in the first place, but let's say we have first name equals John, last name equals Doe. So the first rule says that we can start the variable name with an underscore or a letter. Here we have both the examples. I've started first name with an underscore and last name with, and both of them are valid as of now. Cannot predict what would be the future implementation of, in what can you say, or what the future version can do with this. But for now, it is valid, and we can print out any of these. Print, let's do it this way, whatever the suggestion says, best thing we can do. So yeah, these are both valid types of names. Next rule is that we cannot start with a number. So I cannot start with this. It would throw a syntax error in the very first line. Here we go. Because it is invalid and not the best practice to perform. Next up we have, it can contain letters, digits and underscores. As we just saw, we have used letters and underscores here, but we can also put some digits here and it would still be the same thing. I'll just correct it a little bit. Okay, and I'll save it and I'll run it, the entire thing. So yeah, next rule was that it is case sensitive. So first name 1, 2, 3, 4. Let's remove this for now, and we'll remove this for now as well. We'll remove this for now as well. Remove this letters for now. So first name and first name are not the same thing. The capitalized F makes a difference because Python is a case sensitive language, and it means that both of these variables are different by nature and can contain different values at the same time. Unlike if we are using the same variable, we cannot store different values at the same time. So next rule is that we cannot have spaces or special characters inside a variable name. Let's try it out as well. X at y equals 10. It would not be valid. As you can see, we get a syntax error because yeah, it's not the proper syntax for it. Next up, we have keywords. Keywords are basically reserved words in Python which we cannot use to name a variable. So if we want to check out what all keywords we have, let me just clear this up for a okay. We import the keyword library and we print out the keyword.kw list. It basically prints out all the keywords in Python. These are all the keywords in Python. You can read it if you want. You can pause the video and read it, or you can take a screenshot, whatever you need. Or you can execute the code. It's just 2 lines and check it out for yourself. So yeah, these are the things which we cannot use for naming a variable because they already have a significant meaning in Python, and each of these has a purpose in Python. So yeah, that's about keywords. We'll study about data types now. Okay, what are data types? As I explained that in this. Again, let me just redo it. That would be easier for me instead of spamming Control Z. So yeah, what are data types? And what are data types? So basically, when we declare a variable x equals 10, this part is the variable type. Call it as a var for now. This part is called the data. Data has two components, which is type and a value. So for now, the value for it is 10 and the type is an integer. But if I do it this way, if I put 10.0, then this type changes to a floating integer. I'll just type float for now. But value is not the same now. 10.0 for now. So yeah, that's what type means. Type basically defines what kind of functions or operations we can perform on it. Let's say we have the variable x again, but this time we are assigning the value 10 in the form of a string. What is a string, you may ask? We'll be discussing that in the next slide, or next slide, or one of the upcoming slides. So let's say we have another variable y equals um, 15, and if we perform x plus y, we'll basically be performing concatenation of strings. What is concatenation, you may ask? Well, that's something we'll be covering in one of the future videos. So x plus y in this case would be 1015. Is not the answer we require. If it is an integer, let's erase the quotation marks for now. And this, so we would get it as not this, but we would get what's 10 plus 15, 25. We'd be getting this as answer, which is our required answer in this case. So yeah, that's basically what's an overall purpose of a data type. It basically defines what kind of operations and functions we can use on the variables. So yeah, these are some of the main data types in Python, which is numbers, strings, boolean sequences, sets, mapping, and none type. Let me just explain what I can on the whiteboard. Let's start with numbers. Numbers can be divided upon three different types, which is integer, int. They are the whole numbers. Say 10 is an integer. Another we have is float. Float is basically an integer plus some decimal value. Let's say we have 10.00, and it is a floating integer. Another number type we have is complex number, and it is in the form of 10 plus 1j. J basically represents an iota, which we had in mathematics. You studied well. And it has the value of under root minus 1. So yeah, that's about numbers. We'll be implementing that as well. Let's go to VS Code. So let's say we have a variable x equals 10, y equals 20.0, and z 10 plus 1j. Let's save it and we'll print out each of its type. And the suggestions are pretty clever. VS Code is what I like about it, and they are pretty to the point as well. It already gave me the output before I print out the output for you. So yeah, when we run this, it is an integer, a floating integer, and a complex number. Pretty clear, I guess. I have some examples as well. Let's say we have to count a number of students in a class, and we'll be using integer. If we are calculating the average height of the students in the class, we'll be using the floating integer. But let's say we are doing some complex mathematical operation. In that case, we'll be using complex numbers. Let me just clear this up. If you wonder what I was looking here, I was looking for what I'll have to explain inside strings. So, yeah, bit too conscious in front of camera, so that's a factor. So let's get with the strings now. I think I've explained numbers pretty clearly. Next up, we have strings. Strings basically contain alphanumeric values, characters, and they are enclosed inside quotes. Means that if I have to assign a variable x in the form of string, then I'll have to do it. I can also put numbers in here, or I can also put some symbols in here. Not all the symbols, but some of them, like dash, exclamation mark, full stop, score. This is still a string, and so yeah, that's how we work with strings. Strings are also indexed, and why they are indexed, we're studying that in the video dedicated to strings. They are not made yet, but I'll be making that very soon. So when we do this and we print out its type type X, and we get a string. When I say strings are indexed, which means that they are ordered. They are in ordered form, which means each of the characters can be located individually outside of the string. Like let's say I have to print D right now. So I can do it this way. Print X, then we'll use squared bracket. Why we use squared bracket? That's the next topic. Next topic, or maybe next to next. So if I put in 0, save it and we run it, it should print out D. So what an index is, basically counts the number of characters and it starts with 0. So this is 5 characters, so the maximum index would be 4 and it would be for the H. We do this and we run it like this and we get H here. So yeah, that's how indexing basically works. And forward with booleans. If I have to explain booleans in a really short manner, I can do it like a true or false question, that if some value is true, then something happen. They are basically used in conditional loops, conditionals and loops. I would be clear about that. Conditionals are basically if and else statements, and loops are basically we would repetitively run a specific chunk of code till and unless a condition is satisfied. So yeah, that's about Boolean. We'll be demonstrating that as well. False, false. Boolean. It would print out false. If I do it true, using just true, we print out its type, and it should be Boolean for now. Yeah, bool or Boolean, whatever it's a case. So yeah, I think I forgot to give some examples as well, and it should be pretty fine if I give it right now. So let's say we have strings for now. So where can we use strings basically? Let's again take the example of a classroom. So let's say you are preparing the report card of a class, then we'll have a couple of factors, which is name of the student, we'll have address of the student, we'll have a roll number of a student, we'll have mobile number of the student's parents, mobile number. We'll also have, let's say, grades. Let's say pass or fail as well. So this would be a string because a name is a combination of alphanumeric characters. In the case of name, it's just alphabets, but this case, it's alphabetical, or we can call it alphanumeric values. For roll number, it can be a string, but in most schools, as far as I've been, they are numbers only. But in colleges, I've seen that there are some characters in front of it. So yeah, roll numbers. Let's say we are storing that in integer. Mobile numbers are also a combination of digits, so we'll be storing that in integer as well. Grades, again strings, because grades. Let's say you get a grade, A plus grade, or an F grade. I hope you are not getting F grade, or else that would be a problem. I think I wrote, and I'll write it all up. Let's say pass or fail as a true or false statement, so we can take boolean here. So that covers almost all the data types which we have studied so far, but we have more data types to study. I'll keep this open and we'll refer to it whenever we want. Yeah. Next is sequences. Sequences are basically the data types which can be arranged in a sequential way. Strings are also sequential because they are in a sequence of alphabets. Like uh, we took the example of my first name, is DARSH. So each of the element is in a sequence arranged together. So yeah, lists are, as I called it out, I'll start with that. Lists are basically a collection of whatever data type we can have. Let's say 1323, my first name again. Then let's say 3.14 for save it and will ah, the suggestion is showing out some of the follow-up statement, but we'll not be going with that. Select it like that. We can't, but we can print it out, print the list out, and can see all the elements here. If we want to pick out a specific element, we can do that as well. We can do it like this. Let's say I want to pick out my name. My first name is at 0, 1, 2, third index. So I'll put 3 here, run it, and I'll get my first name right here. Problem, but let be. And if I want to input this, then I can put -1 here, print out this. So what the indexing does in Python is when we move in a forward direction, we are basically moving this way. I'll just take it here, the whiteboard, copy that, and we'll everything. So when we say we are moving forward side of a list, we are moving in this direction basically, moving this way. But when we say we are moving backwards, we start from here, we move this way. I don't think the list has properly been formatted here. Type it out. When I say that we are moving forward inside a list, then I mean that then I mean to say that we are moving this way. X would go from 0, 1, 2, 3. But if we have to move backwards inside a list, we'll be moving this. And the indexes would start with -1, minus this way. That's how basically lists work. That's content of another video, but that's a good overview for lists. Next up, we have tuples. We'll be coming to the use cases as well after we finish all the data types. So yeah, a tuple is similar to a list. I'll just put three, or let's put 4 types of data in here for now. And yeah, they work the same way as the list. Can index as well. Can use indexes here as well. But in case of lists, they are mutable, which means that we can insert an element inside the list or remove an element from the list. But in case of a tuple, that's not the case. Tuples are immutable, which means that we cannot add or remove values inside of this. So yeah, that's about list and tuple. Let's say we have strings now. They is and we print out. Let's say we print out some of the elements from this, and that would be the first three elements. Let's say 0 to print use PYT is pretty popular song by Michael Jackson. But anyways, to the topic. So what we did here is we took a range out of the string. You can do this in list and tuples as well. But strings are also immutable and we cannot add or remove stuff from here. We can only manipulate the stuff inside this. We can slice it out or we can capitalize it or convert it to lowercase. But yeah, that's all about strings. So let's say we are back to this example. Remove this parts for now. So yeah, let's say we have to store grades for now of different subjects. We can store it like pass, fail. They are not grades, they are basically status. Let's say A, B, A, like this. Hope you're not getting this up. Anyways, are a good example. So yeah, that's basically how we can use lists to basically store data in case of this context. And we can also use tuples for this, but let's just use lists for now. Next up, we have sets. Here we go. Sets are basically unordered and contain no duplicate values. Well, that in here. So when we say we have a sets, and we can demonstrate it using curly braces. And here we go. Here's a good example. We'll also put some duplicate values as well. And a zero as well. And we'll print it out. Then it would give out 0, 1, 2, 3, 4, 5. Basically arranged everything in ascending order and removed all the duplicate values. Yeah, that's how sets basically work. So yeah, that's all about sets. Next data type we have is mapping, which I forgot to put inside the presentation. But we just explain that real quick. Take a dictionary. So what we mean by mapping is that we can map different values, different keys to different values. Let's take this example. H3, New York. Do you have any other detail? Let's say this, in this case, we have this is the key and this part is called the value. So when I have to print out it like this, print dictionary, uh, get name, we put this, would give out Alice. So when we do this, basically can get whatever value is stored in here. We can, in this case, we can use it as is this out for us. Let's say students have grades per subject. We can declare it like this. Let's say you have mathematics and you're scoring an A grade in that. Say we have science, A plus grade in that. So yeah, basically that's how we can use dictionaries in this scenario. And next thing we have is none type. I'll put a bit. None type basically represents nothing or no value. So in this, what happens is, uh, I can scroll out, zoom it in better. So in this case, what happens is, uh, let's say we took the variable x equals 10, zoom it on this, I can. Y x equals 10, then x would contain the value 10, and as we use the memory in our point. So when we do this value basically gets stored in one of the memory spaces. But in this case, let's say we don't have a value 10 and we have the value none. Then what will happen? That what will happen is, uh, x would basically point to memory space, but it would contain no value because of course we defined it as none. It would show no value unless and until we happen to change the value of x inside the code somewhere. So until you do that, x would contain no value, and whenever we try to fetch that value, we would get nothing. So if you're using conditional statements or something like that, and we're trying to print x here, then we won't be able to do that because x currently has no value. So yeah, back here. Yeah, in this case, let's say a student was absent for a specific subject. Say he was for social studies, then it would be none here. Because we can assign this as none because it has no value as of now. The student didn't show up at all, so it can be considered as none. So yeah, that's all the data types I had to cover in this video, and we come to the best part of this video. So recently, think about yesterday, I read this Reddit post on one of the subreddits regarding BTech, and the post was revolving around how the Reddit user was unable to write his own codes. He has gone through multiple tutorials and stuff, but when he sat down to write his own code from scratch, it was blank. He had no idea what to do and how to do that. So to help with that, this code challenge is a perfect solution for that, in my opinion, because this question you have to complete and submit to me. I'll be checking that out in one of the videos. That's more video content for me and more practice for you guys. Sounds pretty clear. So yeah, I'll be attaching a screenshot somewhere the screen of the Reddit post, and we'll also provide the link in the description if you want to check it out. And to the code challenge part, let's say, not sure for how long for now. So yeah, for the code challenge part, what we have to do is ask the user for the name, age, and country. You have to store these values inside variables with their specific data types and print out a personalized greeting message describing them. Pretty easy. But before we do that, I'll show you some stuff. How can we take user input? So when we have to take user input, I'll just this also. Pull it down for a bit. So let's say I have a variable x and I want to take user input, then I'll just write it like this. I'll put my statement here. And let's say I just print it out for now. It out like this. We run. Should be asking me. Okay, it's asking me for a number. Let's say enter 10 for now. And Here we get the output as you entered 10. Be clear? And the other thing is, how can we mold this specific thing into our preferred data type? So by default, input statement gives you the data in form of a string. So when we print its type, what am I type, and we put X here, we'll run it. We'll enter the number 12 round, and it's a string. By default, it's taking a string, but if we want to put a specified data type in here, we can do that too. So annoying. Get rid of this. Okay. So when we have to cast this specific data, we can put this into parentheses, and in this case we need an integer. We'll do that. I'll put int here. So whatever data I put in here would be forcefully converted into integer. So enter a number. I'll enter 15 and type is integer now. Let's also print out x for now and integer 15. So yeah, we get the integer 15 now. But let's say I enter something like ABC 14. It would give out a value error because it is not supposed to forcefully convert characters into numbers, which is not possible at all. So yeah, that's how we do take user input and implement that in our code. So yeah, good luck with the code challenge. And because my camera is not working, so I cannot switch to looks so funny. I cannot switch to my cam only screen, but yeah, that's everything I had to cover in this video. And I hope to see you in the next video. You can take the screenshot of the code challenge. And one more thing, please don't forget to subscribe to the channel. It gives the channel a little boost. And also don't forget to like the video. It gives me some pleasure. Yeah, jokes apart. This is important for your learning purpose, and it's very good for strengthening your, what we call it, the basement or your foundation thing. So yeah, you can do one thing. You can just complete the code challenge and copy paste your code inside the comments. I'll check it out and make a video around it if possible. Or you can just upload them on GitHub and provide me the link in the comments. I'll check that out as well. So I'll be waiting for that. And until then, learning and have fun with it. Yeah. See ya.